Got the primary loop going pretty good. Looks looks like everything's really good shape. We don't see bubbles or anything like that. Of course, you can't see bubbles in the pipes. And
Like
this one,
cavitation?
what's that?
Cavitation, could you show us what that is?
Cavitation? Sure, I can show you some cavitation. By the way, class, cavitation. What is cavitation? What causes it?
I think it's basically a disturbance in the system, whether it's pressure or a misalignment of valve where there's actually a pressure drop or a change in pressure in the system.
Very good. It does have to do with pressure on one side and the other side of some component, right? All right, so you talked about valve lineups. One of the things that we can demonstrate cavitation with is our valves. What kind of valve do we have here? Okay, and can we throttle with that valve?
Absolutely.
Yes.
That's what it's for, right? On, off, and throttling. So how are we supposed to operate that valve when we open and shut it?
Slowly.
Slowly.
Okay. Let's see what happens if I manipulate this valve quickly. Uh-oh, what's that?
Cavitation.
There's your cavitation. Now, what is cavitation doing to our system as a whole? It's damaging it. What else is it doing?
Creating bubbles in the system.
Bubbles in the system. It's not efficient.
Don't need it.
We're- What does that cavitation do to our components in our system?
Damage.
Damage them.
Pitting. Like the impellers, it can cause pitting.
Damage,
Corrosion.
pitting, corrosion. We get air binding in our pump. Did we get air binding in our pump?
Right now?
Yes.
We got a little bit on the back side of our impeller, don't we?
Yes, we do.
Sorry. So we can control cavitation by changing pressure by manipulating valves. If we get an air-bound pump, what are our options? Secure it.
Secure
And
paint it.
there you go. So let's secure it and vent it, and let's get rid of that air inside the impeller so that our pump is efficient and is not being damaged. So that's a pretty simple process. So we vent the air out. Are we good?
Looks good.
Looks good. Now, how are some of the other things? If you cannot see these bubbles in the system, how can you detect cavitation without being able to see it?
Hear it.
Can you hear it? How else?
You can feel it.
You can feel it. And what would it feel like? If I touch the pipe during that cavitation, what would it feel like?
Vibration.
Vibration, and sometimes it's referred to as feeling like marbles in the system too, right? That's those air bubbles doing what? Yep, those air bubbles are being created, and they're also when they're compressed, they burst. So that's what you're feeling. Now we don't have any air binding in our pump. We've ventilated that, vented that, and our system's back to where we want it. Some of these concepts are very simple, but sometimes we forget the basics. So it's always good to know the basics. Questions or comments?
So how would manipulating the valve reduce actually the cavitation by just slowly working on it, or
Well,
the other way we can actually...
So as opposed to manipulating this valve rapidly and causing a sudden burst,
Okay.
or slowly changing the pressure, what causes cavitation is vaporization. So if we go slow, we give the system an opportunity to adjust to those changes. If we go fast, we introduce those changes rapidly, and of course the characteristic of the flow is
So
turbulence, pressure change, and vapor.
I mean, I just want to add a comment.
Yes.
We were like moving, throttling with the bottle valve. We observed some little bubble creation here, but I think the fact of the creation will be less compared to when we actually throttle fast with the bottle valve. So is actually minimum when we actually throttle slowly with that compared to when we throttle fast.
That's correct. All right, that's good. So that's your demonstration on cavitation.